Hello, my name is Colin. I am your instructor, and I'm going to talk to you today about solving equations with more than two variables, or more than one variable. So let's swap over to our handy dandy little camera, and we're going to talk about solving equations with two variables, and frankly, this technique can be used for more than two if you need to. So it's fairly straightforward to solve an equation if you've got a single variable. But what happens if you have two? If you've got two variables, say we've got an equation like y is equal to 2x minus 1. It's a little bit hard to tell what would be a solution for this. And the funny thing is, a good question to ask is how many solutions does something like this have? Well, we could start by just plugging in some numbers. Let's just say, let's for example say, let x equal -2 and see what happens. If we do this, then I'll just go ahead and think about this. If x were equal to -2, then I would have y is equal to 2 times -2 minus 1. Okay, y would be equal to -4 minus 1, or y would be equal to -5. So if x were equal to -2, I've got a solution of y is equal to -5. Well, that's if x is equal to one number. How about let x be another number? How about let's let x equal 0. Okay, well, again, we'll do our little thought bubble out here. And if x were equal to 0, we're going to substitute our value of 0 in for x. So y is equal to 2 times 0 minus 1. 2 times 0 is just 0, so y is equal to 0 minus 1, or y would be equal to -1. So already I've got two different solution pairs. Now, the funny thing here is for every single value of x, I'm going to end up with another value of y, or a value of y. So what happens here is I'm going to end up with an infinite number of solutions. And what we'll do is we're going to pair these up in what we call an ordered pair. And that ordered pair is usually listed as x and y. So when we're answering this, if I've got x equals -2, so one of my solutions here is when x was -2, y is -5. This is one of our solutions. When x was 0, y was -1. That was another one of our solutions. Another way of writing this is in a table. So if we set up a table, I'm going to stick with this y is equal to 2x minus 1. We could also just make up a table of values. And we've already tried like -2, and we came up with a value of -5. We tried 0, and we came up with a -1. But I could choose any values we wanted, say 2. And let's just continue on our process over here. So if x were equal to 2, well, I would have 2 times 2 minus 1. That would be 4 minus 1, or 3. So I've got yet another solution. I could try x equals 4. Oh, let's try that. Y is equal to 2 times 4 minus 1. Oh, that's going to be 8 minus 1, or 7. So I've got a lot of solutions here to our equation. Now, the thing that we'll use this for is we're going to graph these. So let's graph our various solutions and see what that overall pattern is, because I hope you've noticed that there was a bit of a pattern here. So when x, remember, if we're graphing, We start here on our x-axis when x was -2, y was -5. 1, 2, 3, 4, 5. When x was 0, so that's right here on the y-axis, y was -1. When x was 2, 1, 2, y was 3. So I go over 2 on the x and 1, 2, 3 up here, 3 on the y-axis. When I have x equal to 4, y was 7. 5, 6, 7. And you can see this pattern. And the funny thing is, if we were to go in between these values, we'd find that all of these meet up. So our pattern is this. When we ask what is the solution to this equation, every single point on this line is a solution to this equation. All right, that's what we've got for now, and I will catch you in the next video.